Lesson 5.5, Performing Function Operations. Our essential question, how do you add, subtract, multiply, and divide functions? You have 3 problems for independent practice. Let's go ahead and take a closer look at these. So, my domains are going to go over here. And I'm being asked to find the f divided by g of x rule, which means I'm supposed to take all of f and divide it by all of g. So here is my f that's going to be in my numerator. And then here is my g, which is going to be in my denominator. So I have 12 divided by 11. So here's my fraction, 12 divided by 11. I have the same base x's. If they're in the numerator and the denominator, the rule is to subtract. So you have a secret ninja 1 minus 1/2. So I have 12 divided by 11 times x to the 1 minus 1/2 is a 1/2. So this is my f divided by g of x function. So now we're being asked to evaluate that at 4. So I have my f divided by g of x function, and these x's are supposed to be replaced with 4's. So evaluating that, I have 12 over 11 times, this is the square root of 4. And I know the square root of 4 is 2. So I have 12 over 11 times 2. We're supposed to multiply fractions straight across, and this is a fraction. So this is the fraction 24 over 11. Now let's look at our domains. First, I'm supposed to look at the domain of f of x. F of x is a vertical line. Here's the vertical parent of just y equals x. This is vertically stretched by 12, which means he is vertically stretched this way. It's not moving left, right, up, or down. And how do I know that? It's because there's no adding or subtracting on either the inside or the outside. So I still forever left and forever right. So my domain is going to be all real numbers. Looking at the domain of my g of x, this is an x to the 1/2. X to the 1/2's parent function looks like this. But this has a vertical stretch of 11, which means it's vertically stretching by 11. This is still the furthest left that this graph is going to go. The last x point you're going to see in use is 0. You're using all these positive x values though. So the domain of g is x is greater than or equal to 0. So if I am then looking for the domain of f divided by g, I'm looking to see what these two have in common. F says use everybody. G says not everybody. But I want x is greater than or equal to 0. So what do they have in common? X is greater than or equal to 0. So I'm going to make an area over here for my domain. And I'm being asked to do f divided by g of x, which means I'm supposed to take all of my f of x and I'm supposed to divide by my g of x. So what is my f of x? It is 0.25 x to the 1/3. And I am supposed to divide by my g of x, which is the negative 4 x to the 3/2. We're going to do whole number divided by whole number, so 0.25 divided by negative 4. I see same base x's on the numerator and the denominator, so the rule is to subtract. So I have 1/3 minus 3/2. 0.25 divided by negative 4 is a negative 0.625. My x's, 1/3 minus 3/2 is a negative 7/6. You're not supposed to have an exponent with a negative number, which means that this entire number is on the wrong side of the fraction. So he needs to be moved. So what is our answer? This did not have a negative exponent, so he's going to stay exactly where he is. The x is now in its happy place with a positive exponent. This is my f divided by g of x function. But we're now supposed to evaluate this when the x value is 1. So we're going to come over here where we have space, and we're going to evaluate f divided by g, 0.625 divided by x to the 7/6, when this x value is going to end up being 1. So here's me replacing my x values with 1. So I've got my decimal on top. My denominator is a radical. It is the 6th root of 1, all raised to the 7th power. So I have my decimal in the numerator. What is the 6th root of 1? That is 1. I have my decimal in the numerator. What is 1 to the 7th power? That is 1. So negative 0.625 divided by 1 is negative 0.625. And that's my answer. Now domains. First we need to look for the domain of f of x. This is x to the 1/3 power. Our parent function looks like this. It's got a vertical shrink. So ours vertically shrunk and it just kind of looks like this instead. It's still always to the left and always to the right. So his domain is all real numbers. Looking at my domain of g of x, he's an x to the 3/2 power. So he ends up looking like this. We're vertically stretched and reflected. So he is actually more like this instead. His last point is still right here. He did not have any adding and subtracting, either inside or outside. So he's not moving left, right, up, or down. So he's just reflected and stays where he is. The last x value he uses is 0. So everybody over here, which is all the positive x values, are still used. So his domain is x is greater than or equal to 0. So we're going to look. What do these two have in common? And that is the answer for the domain of our new function. F says use everybody. G says to only use x is greater than or equal to 0. So what do they have in common? X is greater than or equal to 0 is what they have in common. So that's the domain of our new function. Now something that we forgot to look at when solving for this problem was that this is the first problem we've had where we had a denominator in our answer and the variable was in the denominator. If this happens, you need to make sure that your values of x, the values of x that we chose, do not leave this problem undefined. What does it mean to be undefined? That means that this denominator can never equal 0. So this denominator of x to the 7/6 power cannot equal 0, because then that would make this problem undefined. What value of x would make this statement true? Well, if I wanted to undo the 7/6, then I needed to raise this exponent to its reciprocal, which was 6/7. 7/6 times 6/7 multiply to 1, so they one each other out, and I am left with x on the left side. Well, if I raise this side to 6/7, I need to raise this side to 6/7. 0 raised to any exponent would end up giving me a 0. So this is the correct function, but we know that if x is 0, that made this problem undefined. So we need to have one characteristic left in here. We need to say that x cannot equal 0, because if x equals 0, this function is undefined, and then we can't use it. Since we now know x cannot equal 0, that means even though this was the domain of what these had in common, because the domain includes this x value, and we know x cannot be equal 0, we need to remove that equal sign in the answer. So the domain of f divided by x is only x is greater than 0. Because if it equaled 0, we would have an undivided function, which we cannot have. Last problem. Here's my space for my domains. I am being asked to do f divided by g of x, which means I need all of f, and I have to divide it by all of g. My f rule divided by my g rule. So I have the fraction 36 divided by 4. Looking at same base x's in the numerator and the denominator, the rule is to subtract. So it's the numerator's exponent minus the denominator's exponent. 36 divided by 4 is 9. Looking at my x's, 7/4 minus 1/2 is 5/4. So this is my f divided by g of x rule. Now we're being asked to evaluate this f divided by g of x rule when x is 16. So these x's are going to get replaced with 16s. And we're going to evaluate. So I have 9 times. This is the 4th root of 16 all raised to the 5th power. So I need the 4th root of 16, which is 2. So I have 9 times 2 to the 5th power is 32. 9 times 32 is 288. So my f divided by g at 16 is 288. Now let's look at the domains. I need the domain of f of x. The parent function is x to the 7/4, which looks up something like this. It's vertically stretched by 36, which means it's even taller and vertically stretched. The last left point ever used is still the same 0 point. And I see it still goes all the way to the right, which means my domain is x is greater than or equal to 0. Now let's go ahead and look at the domain of g of x. Parent function is x to the 1/2, which looks like this. Vertically stretched by 4, then it looked a little bit more like that. Its last point is still right here at the 0. And I see that it still uses all these positive x values. So his domain is also x is greater than or equal to 0. So if we're figuring out our f divided by g of x domain, what do these two have in common? F says I can use all the x is greater than or equal to zeros. Domain of g says x is greater than or equal to 0 as well. If they say the same thing, then the domain of our new function is also the same thing, because they share it all in common.